Glycolysis, which occurs in the cytosol, oxidizes glucose of two molecules of pyruvate, which is right there. Produces 2 NADH and produces a net of 2 ATP by substrate level phosphate within the mitochondria. The oxidation of 2 pyruvate yields 2 NADH2 and 2 acylic CoA. 2 acylic CoA feed into the citric acid cycle, which yields 6 NADH and 2 FADH2, as well as 2 ATP by substrate level phosphorylation. NADH and FADH deliver electron to the electric transport chain, where they finally pass into O2 and forming H2O. The electron transport chain pumps H plus into the intermembrane space. The resulting H plus gradient is tapped by ATP synthase and produces 28 molecules of ATP by oxidation. Thus, this total yield of ATP molecule per glucose is about 32.
Shows that photosynthesis and cellular respiration together provide energy for living organisms, which takes place in the plant cell chloroplast from the sunlight energy from the sun. The energy of sunlight is used to rearrange the atoms of carbon dioxide and water to produce sugar and oxygen. In cellular respiration, CO2 is consumed as sugar is broken down to CO2 and H2O. The cell captures the energy released in ATP. Cellular respiration takes place in the mitochondria. The CO2 and H2O released by cellular respiration are converted through photosynthesis to sugar and O2, which are then used in respiration.
Photosynthesis makes sugar from CO2 and H2O, providing food and oxygen for almost all living organisms. In stage 1, the light reactions, which occur in the thalcoid membranes, 2 photosystems in the membranes capture solar energy, energizing electrons in the chlorophyll molecule. Simultaneously, water is split and O2 is released, and electrons are funneled to the photosystems. The photoexcited electrons are transferred through an electron transport chain, where energy is harvested to make ATP by the process of chemiomosis, and finally NADP+, reducing it to the high-energy compound NADPH. The chloroplast sugar factory is the Calvin cycle, the second stage of photosynthesis. In the stroma, the enzyme ribisco combines CO2 with RUBP, ATP, and NADPH are used to reduce 3-PGA to G3P. Sugar molecules made from G3P serve as a plant's own food supply.